Hey, how's it going? This is Mr. Hernandez, and I'm going to be going over solving exponential and logarithmic equations. And the technique that I'm going to use more often is converting an exponential to a logarithm and vice versa. So I'm going to do a couple of examples. So here's example one. So if you have, you know, an exponential equation, which is the base, the exponent, and the other side, you could convert it. So this is you're basically wanting to get this x in a place where you can actually do stuff with it instead of having it be in the exponent. And so what we're gonna do is we're gonna convert it to logarithmic form. So again, this is the base, this is the exponent. Here's a so remember, we're gonna do a couple of things here. We're gonna write it as a log. The base of the log is the same as the base of the exponent, which is 8. So the base stays the same. And then the other thing you're gonna do is switch these two. So instead of 8 being with this, 8 is gonna be now, the 12 is gonna come over here with the 8. And then the x minus 4 now, instead of being the exponent, it's going to be on the right side by itself. Okay, so now that we've converted it, we can actually simplify. And that's the reason why we could simplify, is because you basically have, let's see, okay, got it. All of this you could put in the calculator. So log base 8 of 12, let's see. So log base 8 and then 12 is 1.1949. Okay, 1.1949. So that's an approximation. And you could use these approximation symbols if you're rounding. And then so that step was I would call that simplifying by putting this into a calculator. And then now we can add the 4 here to both sides. And that's how we can get this x by itself. It's approximately, and then 1 plus 4 is 5, so it's 5.1949. And that's pretty much it. Let me give you another example. So if you were to do something with let's say logs, let's see, you would have, let's say, log base 2 x minus 1 equals 2. Okay, so again, you have the base, you have this number and the other number. Okay, so what we're going to do is take this base and we're going to convert it to an exponential form. So in an exponent, the base is this main number, and then you're going to end up switching these two out. So instead of the 2 being with this, the 2 is going to be with this 2. So I'm going to write that 2 as an exponent, and then the x minus 1 is going to be on the other side. Okay, so now we could simplify this. So remember, we can since this has an x, we can't really simplify this. We can't put it in the calculator to give us a number. But when we convert it, now we have something we could put in the calculator. So 2 squared is 4. And then we could, do the last step and solve. We can solve for x by adding 1. So the main trick is, you know, getting that, being able to have something to be able to put in a calculator, you know. Okay, so I'm gonna go over a couple of more, you know, challenging ones. Another one would be, let's see. Okay, let's just try this one. 10 raised to the 2x minus 6 equals 146. So before we can actually solve this, before we can convert it, I mean, from you know, because we can't put this in the calculator because it has an x. But we want to convert this to a logarithm. However, this minus 6 should be moved over. I mean, if we can, we want to isolate the exponential form. We want to isolate the exponential expression, which is this. We want to get this by itself. So in order to do that, we're going to move that negative 6 first by adding 6. And so now we have that expression by itself. And then we can convert it. So let's convert this now. And again, the base is this. So that base is going to stay the same in the logarithm. So log base 10. So that's going to be a smaller 10. And then these two are going to switch. 152 is going to be on the left, and then 2x is going to be on the right. And so now we could actually put this in the calculator. We're going to simplify this. So log base 10, 152. Okay, 2.1818. So that's an approximation. So I'm going to use these two squiggly lines to represent that as an approximation. And then we're going to go ahead and solve. So now we have the x. We could just get rid of this coefficient by dividing by that coefficient, by the 2. And so now x is by itself. And then that value divided by 2 is, let me see, divided by 2, 1.0909. So that's a little trickier, right? Because we weren't able to convert it right away. We had to isolate that expression. And I'm going to do one more with the log, where you have to isolate the logarithm. So let's see, 4 log base 3 to the 3x equals 20. So again, this is the expression here, and we want to isolate that. Because a log only has the number that's the base and then the number that the log is applying to. So we got to get rid of this 4. So in order to get rid of that 4, well, the 4 is multiplying, so we're going to go ahead and divide it. And so now we have this log base 3 of 3 to the x by itself. 20 divided by 4 is 5. And then we could go ahead and convert it. So it's a log, so we're going to convert it to an exponential function. This 3 is the base, so we're going to make the exponent a base, having a base of 3. These two are going to switch, so the 5 is going to go on this side with the 3, but now the 5 is going to be an exponent since it's an exponential expression, and the 3x is going to go on the right side. Okay, so the good news here now is this is something we could put in the calculator. We can actually simplify this. So 3 to the 5th is, let's see, 243. So 243 equals 3x. And then we could now divide by this coefficient here. Divide by 3 to both sides, and you have x equals, let's see, 243 divided by 3 is 81. Okay, so you know, these are just a couple of examples, but of course you can have, you know, more things to get rid of. You know, if you have to add or subtract to isolate this expression, or divide, multiply to isolate the expression. But you're basically going to do PEMDAS backwards, okay? So that's the main thing. I know I didn't talk about this too much, but it's the same as solving any equation. You're going to do the addition, subtraction first, then multiplication, then division, which we did here. And then the exponent, you could think of it as exponential logs. So exponents and logs. And logs actually are at the very top, and that's where you convert from one to the other. So that's the last step, and then after that you could kind of start over again and do the addition, subtraction, multiplication, division once you are able to get that x by itself instead of just converting it and simplifying.